All right, so we're going to start first with reliability. So reliability is really just about the consistency of your measurement. So if you were to measure, use the same measurement over and over again, do you get similar values if you have the same sample? And so, for example, if you have a scale that is appropriately tuned, I guess, every time you step on the scale, you're going to get the same measurement if it's, same day, same time, you haven't eaten anything. But if you have a scale that's a little bit off, you might get a wide range of values each time you step on the scale. So the first scale is very reliable. Each time I measure using it, I get the same value. That means it's reliable. It has the same measurement each time I do it. But the second scale is not reliable because each time I make a measurement, I get a different value. Okay, so that's what I mean by consistency in this sense. And so there's three major types of reliability: test, retest, inter-rater, and internal reliability. And these are all really dependent on your experimental design. Test, retest is the most common one that I've seen in my personal literature, but I know a lot of people, especially in social psychology, use inter-rater reliability many, many times, or pretty much every time they run an experiment. And internal reliability is also quite common. And so there's a lot of ways to do this. It's fairly common to run a correlation. I'll talk about why that is in a second. I'm sure you've seen correlations in stats previously, so hopefully you know what I mean when I say correlation, but I will be covering it in a future module. Okay, so let's talk about these. So when I kind of have this nice image, this will split up both your validity and reliability all on one screen so that you have it when you're going forth and running your own experiments and designing your own experiments. And so when we're looking at the reliability section of this image, we have the test-retest reliability. So that means that if I run the test over and over again, am I getting the same values? That's why it's called test-retest. So it's basically the same thing that I was talking about when we were talking about the scale. If I step on the scale over and over again, am I going to get the same results? So test-retest is a similar idea. Internal reliability is when you're looking at the scores on items on the questionnaire. So if you have like a questionnaire and you want to look at particular questions, you can look at the scores that people are giving on particular questions and see if those are consistent. And then inter-rater reliability is when you have raters. So typically in observational experiments in particular, when you make an observation, you might film it, and then you have a group of people, like 3 or 4 people, code for something that you're looking for. So for example, if I was looking for well-being, which is the construct that I started with in this module, I might film someone doing a particular experiment, and then I have particular things that I want to look at that are related to my construct. So how often they smile, for example. And so to calculate that, I will have that film and I'll give it to 3 separate people, and each of them will count the number of smiles that the participant had. And then I will do that for every participant. So my 3 raters will look at each video for each one of my participants and give a rating for how many times they smiled. And then I'll just look at the reliability, or the reliability between my raters. So are the ratings consistent between those 3 people? So in this case, 2 coders' ratings of set of targets are consistent with each other. It just means that I have multiple people doing some sort of coding for me. Coding being, taking information from an observation and then seeing how reliable those are across the raters to make sure that they're reliable, and so that I know that my measurement is going to be valid. Because if I just had one person, maybe that one person consistently missed a bunch of smiles, or didn't think they were smiling. They thought it was a grimace or something. And so the more coders you can have, the more consistent, or hopefully the more consistent you can get for your measurement. Okay, I kind of went off on a tangent there, but hopefully that makes sense. I think I also have a slide on it here. So test-retest reliability. What you'll want to do is you'll have a group of people, and you'll run the same test over and over again, and then you'll look at your data and basically do a correlation between the two tests. So it might look something like this. Well, okay, so I guess I went to internal reliability, but you'll basically have a graph, and then you'll have test 1 and test 2, and you'll just see if the scores match up, right? It's the same sample, it's the same participants that you're running this test over and over again. And so you should have a really strong correlation between the values that you get for each participant. So you just make a graph, and then you look at, is there a strong correlation between the two? Okay, so that's kind of the easiest one to understand. Test, retest, run the experiment over and over again and see if you're getting the same results. Interrater reliability, so this is looking at rating. So here maybe I'm rating on something like well-being. They actually just give a score for how happy they thought that the participants were. And then I have multiple raters, and then I just want to look at, is there a correlation between the ratings between them? So I have different participants. So here's one participant, Jackie, and another participant, Jay. Jackie was not happy in this particular study if a lower value meant less well-being, less happy. And that is consistent between both of my my raters, or each time that they did a rating. So Matt and Mark's ratings of Jackie were similar. Matt's and Mark's ratings of Jay were also similar. And that was true for all of the participants. There's a strong correlation suggesting that they are providing the same measurements, right? They are separate people, but they are still getting the same, I'm still getting the same measurements from them, suggesting that the coding is consistent, which is good because I want to make sure my measurements are not just from one rater, that rater happens to be doing something weird, and so my measurements would be off. I have multiple raters and they are all consistent, therefore I know I'm measuring what I think I'm measuring. Okay, so here's an example of maybe Peter and Mark. Peter's ratings were much different than Mark's ratings, so we're not getting a strong correlation, right? Peter thought that Jackie was very happy, but Mark thought that Jackie was very sad if we were measuring well-being. And so, yeah, it's not consistent here. And so I would have to go through, maybe get different raters and figure out what's going on to make sure that my measurement is reliable. Okay, and so that is the reliability section. So we've talked about self-report, observational, and physiological measurements and how to operationalize those. I don't know why I'm struggling with that today. And then you have scales of measurement. So this is just the types of measurement that you have. Nominal being categories that don't have order. Ordinal can be numbers or categories that do have some sort of order. Interval are numbers that, again, are ordered, but now the difference between the values are consistent. And then the ratio 0 has some meaning. It's ordered. Differences between the values have meaning, and that sort of thing. Okay, and then we talked about reliability and the 3 types of reliability: test, retest, Interrater, and internal reliability. Okay, so hopefully that all makes sense, and we will move on to validity in just a moment.